Listen as if the night itself has leaned closer. Stars breathe their pale light across the roofs, across the fields, across the soft fabric of your thoughts. There is a hush that only arrives when the world has put down its weight. In this tender hour, questions sound different. They unfurl slowly, like a fern at dawn. They are not in a hurry to be answered. One of them perhaps arrives like this. If space can bend, could it fold? If the great black water of the cosmos can ripple, can it also tunnel? And if there were a passage quiet as a breath, thin as a thought between distant points in the universe, what would it feel like to step inside? We call such passages wormholes. A nickname, playful and homely, for an idea both exquisite and serious. A tunnel through spacetime itself. Not a tunnel carved through rock or ice, but through the invisible threads of distance and duration. A bridge, a throat, a shortcut that acts like kindness between faraway places. Two mouths, one hidden corridor. You enter one place and emerge, impossibly soon, somewhere else. But before we go inside, let's lie here for one more moment, letting the sky's dark velvet fill our eyes. The world moves gently around us. A moth taps the window. Somewhere a late train murmurs across rails. All the small sounds of a night that doesn't know you are thinking of impossible doors. You close your eyes. The map of the heavens glows on the back of your eyelids. And then the map tilts, like paper folded in a patient hand. What would it be like to step across such a crease? Would you feel a slope underfoot? A hollow wind? Would your heartbeat echo strangely from the walls of geometry? If gravity is not just a force, but the shape of spacetime, could those shapes gather into a tunnel with a smooth throat and a pair of round mouths? Could light itself turn its head and pass through? The language of the universe has a grammar that is not made of words. It is made of curvature and connection. General relativity, Einstein's grand poem, tells us that mass and energy don't sit on space, they sculpt it. A star does not tug on you across a gap. It asks the space between you to bow, and then you follow the curve. What we call gravity is the experience of moving along a bend we cannot see. From that idea, the possibility of tunnels seems not so outlandish. If space can be curved, it can perhaps be curved in clever ways. What we would call a wormhole is one such cleverness. A region where the geometry is arranged so that a traveler, moving always locally forward, can arrive somewhere else non-locally, faster than a beam of light would, if it were forced to stitch along the outside surface of space instead of slipping through the folded interior. There's a temptation to imagine it like a subway through the city of the cosmos. But the truth, as always, is gentler and stranger. A wormhole is not a hole carved into something else. It is that something else wearing a different shape. The tunnel is the world. The walls are the structure that joins one distant place to another, like two beads on a string someone has pulled through the cloth. We want to ask, what happens inside? Not at the rim of a black hole, not in the glow around a quasar, but inside a wormhole. If you were small and patient and quiet enough to be let through, what would you sense? What would your watch say? How would your path feel under the soles of your thoughts? But to answer that, we need to move slowly. The way you move when stepping into a darkened room where others are sleeping. We need to let the science's eyes adjust to the dim. We need to trace the idea back to the first sketches that drew a throat between two regions of space. We need to learn the shape of the tunnel, the pressure of its walls, the light that might touch your face along the way. So hold this question gently, while the night breathes around you. If a wormhole opens like a round, dark mouth in the fabric of the universe, and you step toward it, what happens just beyond that mouth? What happens to your body, your time, your sense of near and far? We'll go there. But first, we'll learn how such a door is imagined and how it might behave if it can be persuaded to stay open. The first wormhole to appear in physics did not arrive with fanfare or neon or the hum of an engine. It arrived quietly through mathematics, like a river discovered on a map before any foot found its shores. In 1935, Albert Einstein and Nathan-Rosen examined the geometry of a black hole, the simplest kind, perfectly round, uncharged, unspinning, and noticed that if you drag the geometry into a larger, mirrored picture, the solution appears to have two exterior regions, not just one. A bridge connects them at a narrow waist. Later, physicist John Wheeler would give this structure its evocative name, a wormhole. Think of a black hole's solution, in its purest, cold form, as a kind of funnel cut into spacetime. The throat seems to plunge down to a point. But when Einstein and Rosen extended the coordinates, they found that the bottom was not a single termination. It was a passage, pinched thin, that opened into a second universe. It was a bridge that did not take you around the outside of space, but under it, to somewhere that looked suspiciously like somewhere else. But in that early picture, the bridge was a mirage of time. It winked shut faster than any traveler could cross. Imagine a tunnel whose walls race together at almost the speed of light, sealing before your first footfall touches the floor. That is the Einstein-Rosen bridge, a non-traversable connection between two regions that exists in the full mathematics of spacetime, but collapses too quickly to admit passage. A door that never stops moving long enough to be walked through. How do we know this? Not from an intuition of stones and bricks, but from the paths of light itself. The clearest way to understand a geometry is to ask what light will do. Light is pure honesty. It moves always along the straightest possible path through the curved world. Those paths called geodesics tell us where space is gentle and where it clenches like a fist. When you draw the geodesics through the Einstein-Rosen bridge, the light cones tilt and narrow and then pinch until there is no longer a future that permits crossing. The throat is there in space, but not in time. It is a place without a tomorrow for travelers. Even so, even in this non-traversable form, the idea of a bridge changed the way physicists saw spacetime. It suggested that geometry could be more than a landscape of hills and valleys around heavy things. It could include tunnels and piercings. It could be knit, sewn. It suggested that the far might be reclassified as near, if only the shape would allow. And it raised a question that hummed in the back of the mind for decades. Could a wormhole be kept open? Imagine now the approach. You are drifting through quiet interstellar blackness. Ahead, a dark circle cuts the star field like a perfectly round midnight that has forgotten to be night only in that place. Around the rim, light from behind is bent into rings and arcs, intricate as dew on a spider's web. This is gravitational lensing, the way gravity bows light into loops. As you come closer, the patterns sharpen. You see multiple images of the same far-off star, stacked in rings that ripple. Space is telling you something about the tunnel's mouth, that it squeezes geodesics into gathered braids, that it draws distant points into a halo of duplicates. Do you feel gravity pull? Not like a fall into a black hole. If this is a wormhole's entrance, shaped for passage, The geometry can be arranged so that tidal forces are gentle at the mouth. No tearing, no spooling of the body. It might feel as if you are heading into a valley, but without the rush, without the panic. Like stepping down a mossy path where each footfall is held and guided. The stars behind you dim in a ring. The stars ahead are not stars from here. They are from somewhere else. Yet you are still here, and your watch ticks modernly on. But the Einstein-Rosen bridge won't let you through. Before your ship can reach the waist, the throat structure collapses. Gravity is not just a pull. It is the warping of time, too. And inside that early bridge, time twists in a way that closes futures like shutters. You can look across, but only for a heartbeat. You cannot cross. The question became, is there any geometry that looks like a wormhole, behaves like a wormhole, and does not instantly betray your hope of using it? In the late 20th century, a pair of physicists, Michael Morris and Kip Thorne, decided to ask that question carefully, with the scientists' full tenderness for what is possible, and the storyteller's care for what a traveler would actually feel. They wrote down what the geometry would need to be like for someone to enter one mouth and emerge from the other without being crushed, without passing through a horizon, without needing to break the cosmic speed limit locally. Time flows forward for you. Your heartbeat is calm. Light can move in both directions through the throat. You can see the other mouth as a disk, the way you can see the mouth of a cave from inside when the sun is low. What functions in the fabric would need to be tuned to make it so? Their answer was startling, and it led to a new kind of mystery, one that hums still, quietly, like a refrigerator in a dark kitchen. Yes, a traversable wormhole is permitted by the equations. Yes, it can be arranged so that tides are mild and time behaves. But to keep it open, to stop the throat from pinching shut under the burden of its own curvature, the universe demands a rare resource: negative energy density. Not the absence of energy, the arithmetic opposite. The kind of energy that, instead of deepening the curve, lifts it. Anti-gravity, in effect. Exotic matter. Is negative energy real? In a way that matters for tunnels? This is not a simple yes or no. The quantum fields that fill even empty space can, in specific arrangements, act as if they have negative energy relative to the vacuum around them. The Casimir effect, the gentle tug between two very close mirrors, seems to speak softly of this. In that narrow gap, some modes of the field are excluded. The energy dips below the outside baseline. It is as if the vacuum has been persuaded to give up a little of its rest. A negative pressure appears, easily measured in a quiet laboratory. Could such effects, scaled and stabilized, prop up a throat? Could the positive pressure urge to pinch be balanced by a carefully engineered negative pressure that holds it open like the ribs of an umbrella under wind? This, then, is where we begin to walk inside, not with engines and steel, with geometry and the faint, strange resources of the quantum world. Stay close. The path ahead is subtle. You might not feel your weight change, but in the mathematics, the weight of the vacuum itself is being rearranged. We are almost at the mouth. The ring of distorted stars ahead is a mirror into another sky. You draw a breath. Your hand hovers over the control to nudge your ship forward. You wonder quietly, if the throat holds, how will the inside feel?
The whisper that carries us forward now is the Morris Thorne picture of traversable wormholes. It is as if engineers of space, working with equations instead of steel, have tuned to dials in the fabric. One that controls the redshift-away clocks and light slow or hasten near the tunnel, and one that controls the shape itself, the flare of the throat. Turning those dials correctly makes a passage that a traveler can breathe in. In their work, Morris and Thorne wrote conditions a human would care about. No horizons, so that you never find yourself trapped behind a one-way gate. Weak tidal forces so that your body is not stretched between head and heels like taffy. Finite stress so that the materials of your craft or the imagined scaffold of the geometry are not asked to endure the rage of infinities. They treated the traveler as a guest, and the geometry as a host that should be hospitable. What would you sense inside such a wormhole? Close your eyes, you have just crossed the mouth. The ring of lensed starlight contracts behind you into a circle, then an outline, then a halo. Ahead, another halo enlarges. If the tunnel is symmetrical, the midpoint is a place where the view forward and backward look the same, a coin with two faces, each a doorway to a sky. Gravity feels ambiguous. Your stomach does not drop. You are not falling in the carnal way falls feel. Instead, you are following a path of least effort through a space that happens to be curved in a way your body cannot directly sense. You can turn around if you wish and see light from both sides move through the throat with you. It does not pile up into a furnace because the geometry has been tamed so that redshifts are bounded. The brightness stays sane. You could read by it, perhaps, if there were letters to read. The inside is not a place with walls and ceiling. It is the space that connects. But your senses are evolved for surfaces. So, how to imagine it? Think of entering a fog where the notion of far and near is subtly altered. Call out, and your echo returns not from a wall in front of you, but from a geometry that roots sound differently, as if it were bouncing along curves you can't see. Or think of how a lens changes the way the world walks into your eye. Straight lines bend, circles stretch, angles lie. Inside the wormhole, all of space is lens. Your clock, there it is, ticking, behaves itself. The rate doesn't swing. If you've heard that gravity makes time pass differently, you are right. But the Morris Thorne wormhole keeps those differences mild and well-behaved. You and a friend waiting outside with a watch will agree closely on durations. You won't return aged by centuries while they have barely blinked. This is part of the hospitality. You are a traveler, not a lab mouse in a time trap. Underneath these gentlenesses lies the stern demand for exoticity, the negative energy, the thread that holds the umbrella ribs apart. Classical matter, the kind that stars and rocks and you and I are made of, obeys energy conditions. Roughly, energy density is positive. Pressures push rather than pull in peculiar ways. These conditions guarantee that gravity focuses, that light rays converge, that no free lunch of shortcutting exists. But exotic matter breaks those classical promises. It allows geodesics to defocus, to spread, to avoid meeting and pinching the throat shut. This is the architectural secret of the passage. Is this truly real or a clever mirage from theory? Quantum field theory suggests there are ways to summon negative energy for a time, in a place, within limits. The Casimir plates whispered this to us from their cold, narrow gap. But nature is careful. The same quantum rules that allow negative energy also bound it with inequalities limits on how much, for how long, and how spread out. You can borrow negative energy, but you must repay it in a way that keeps the whole balance sheet of the vacuum honest. Physicists like Larry Ford and Tom Roman explored these constraints, proposing inequalities that act like accountants for energy flows. They warn that the kind of sustained macroscopic negative energy needed to prop open a human-sized wormhole might be beyond the universe's patience. The throat wants a series of continuous deposits. Quantum mechanics permits only brief dips and localized deficits. You can bribe the geometry for a moment. You cannot buy it outright. Yet the idea refuses to let go. Even within those limits, theorists dine on possibilities. Traversable wormholes might be tiny, used by particles rather than people. They might be fleeting, but revive if spurred by the right couplings. They might be stabilized not by static negative energy, but by clever choreography, pulses, symmetries, couplings across boundaries that make the geometry momentarily permissive. Here, the story folds back into a very human moment. In the late 1980s, a novelist, Carl Sagan, wanted a scientifically honest device to send his protagonist across the stars in contact. He asked Kip Thorne for help. Thorne, with Morris and later Olvi Yurtsever, built the blueprint for a gentled wormhole precisely to answer this narrative need. This is rare, fiction sending science to the chalkboard and asking for grace. Science answered with equations, but also with empathy for the traveler. That paper is now a classic, and its kindness toward the experience of crossing informs how we imagine what happens inside. The inside is not empty of danger. Light passing through can, in some designs, be blue shifted, concentrated. If you are not careful, the tunnel can fill with radiation like a whistle filling with sound. The walls, if we can call the curvatures walls, can reflect or trap high-energy photons in unstable dances. Quantum fields respond to boundaries and bends with fluctuations. The very act of making a traversable region can invite violent feedback, a quantum back reaction that grows like a whirlpool, threatening to choke the path. Juan Maldacena and others explored this, showing how a wormhole that appears generous can turn punishing as quantum effects push back. So, a traveler's path must be choreographed. The dials must be tuned. The tunnel's redshift must be tempered. The throat's flare must be sufficient to keep tides gentle, yet not so permissive that light piles up catastrophically. You move through, eyes wide but calm. You see the world at the far mouth expand like a dawn. You have not broken any laws. Locally, you never move faster than light. Globally, you have threaded a stitch through the cloth that sews two distant patches together. But there is a deeper whisper now, so soft you have to lean in. It says, perhaps the very existence of bridges in space-time is tied to another kind of bridge, one not made of geometry at all, but of quantum ties between particles. Perhaps wormholes and entanglement are two views of the same connection. Perhaps inside a wormhole is also between two quanta that share a state. If so, then what happens in the tunnel is not just a walk through space, but a walk through relationship. We will follow that whisper. We will step from the smooth, macroscopic throat to the granular, shimmering mathematics of the quantum world, where space is not given, but made, where the length of a path is counted in bits of information, where, in the strangest turn of all, a message transmitted by a carefully arranged protocol looks from a different vantage, like a traveler slipping through a tiny, momentary throat. Hold the image of your ship, suspended in the fog of the throat. Around you, light arcs like ribbons. Ahead, the far mouth brightens, and in the simplest particles, in the quiet hum of vacuum, another kind of mouth may be opening.
In 2013, a proposal with the cadence of a riddle entered the conversation. A equals EPR. The letters refer to two stories from different shelves. ER for Einstein-Rosen, the Wormhole Bridge. EPR for Einstein, Podolsky, and Rosen, the trio who, in 1935, articulated what we now call entanglement. The way two particles can be so deeply correlated that measuring one instantly tells you something about the other, no matter how far apart they live. Juan Maldacena and Leonard Susskind suggested that these two bridges, geometric and quantum, might be the same kind of thing told in two languages. A wormhole can be seen as a geometric avatar of entanglement. Entanglement can be seen as the quantum thread that, when woven densely, becomes space itself. If that intuition is even partly true, it changes the feel of inside. It's no longer just a tunnel through existing space. It's a place where space is being actively maintained by patterns of correlation. The walls are the result of relationship. The length of the passage is measured in how entangled two regions are. Your journey becomes an exploration of structure in information, manifest as geometry. Soon after, a precise, operational way to make a wormhole traversable entered the stage, not in our universe directly, but in a controlled, theoretical playground known as anti-de Sitter space. And by using the holographic principle, which suggests that what happens in a region of space can be described fully by a theory living on its boundary. In that setting, Ping Gao, Daniel Jaffrus, and Aaron Wall showed that by coupling two entangled systems, two black holes that share a quantum state, one can thread a pulse of negative energy through the bridge, temporarily making it traversable. Send a signal into one black hole. It emerges from the other. A traveler, if one could be miniaturized into the quantum furniture, would have the experience of crossing a wormhole. From the perspective of the boundary theory, the laboratory where we manipulate qubits, this is a teleportation protocol. You entangle two systems, perform a measurement here, transmit classical information there, and reconstruct the message. Nothing moves superluminally. No law is broken. But through the lens of the holographic dual, where the entangled pair is described as two mouths in a shared spacetime, the same operation is a little miracle of transit. The inside is the process by which correlations guide a message across. This insight surges out of theory into experiment in a gentle, early way. In 2022, a team built a toy holographic model on a quantum processor and implemented a version of the Traversable Wormhole protocol. The signals behaved the way the dual description predicted. This was not a wormhole in our sky that you could fly through with a ship and a window. It was a small choreography of quantum states whose bulk avatar resembled a throat being briefly held open by a negative energy shock. And yet, as a demonstration, it was profound. It whispered, the fabric of inside-ness might be quantum all the way down. Pause here, inside your imagined tunnel. Imagine the walls are not stone, but woven statistics. Imagine that when you run your hand along them, they are warm with the combinatorics of all the ways the world can be arranged. The throat flares in proportion to the abundance of shared patterns between the mouths. When those patterns thin, the tunnel narrows. When they thicken, the tunnel yawns open. What a strange sensation, that to move through space is to move through the relationship inventory of the universe. And yet, whatever its quantum skeleton, a macroscopic wormhole, something with a throat as large as a room, still must obey the discipline of general relativity. The traveler is large. The walls must hold. The lights must not build into a fire. What would you see, really, if you had the privilege to cross? The lensing would be your first companion. Outside the mouth, the sky shatters into repeated features. A bright ring called the photon sphere may mark where light orbits temporarily before plunging inward or escaping. Step inside, and the view reorganizes. The far mouth draws your gaze like an opening in a garden hedge. Around its rim, the sky from the other side is compressed into a thin, bright halo, the limb of a world you have not yet stepped into. If you turn your head slowly, you might see light paths wrap around the throat in intricate spirals. A star from there, a star from here, overlapping in a dance of optics. The notion of distance fiddles with your expectations. If you send out a pulse of ping from your craft to measure how far the walls are, the answer depends on how you ask. The shortest distance along the geometry's interior might be quite short, while the path that goes around, outside the tunnel, is vast. This is the heart of the shortcut. Inside, geodesics change their minds about who counts as near. You are held by a place that makes far things neighbors. What about sound? In space, we say there is no sound. Here, too, the vacuum keeps quiet. But were this tunnel to thread an atmosphere-filled region, the acoustics would be uncanny. Whispers would arrive from odd directions and at odd times. A clap might ricochet around in a tone you do not recognize. The walls being buildings of curvature, shape not just the path of light, but of any disturbance. The inside would sing gently of its own construction. Can nature make such a thing without our engineering? Our telescopes have learned to read gravity's signature in everything from the flicker of quasar light to the shadows of black holes. A natural wormhole might betray itself through unusual lensing. Duplicate images from a source that appear in odd, unpaired ways. Time delays between light paths that do not fit the usual models. Perhaps even a silhouette shadow that refuses to match any black hole's playbook. Some theorists have proposed that a wormhole might mimic a black hole from afar, but differ subtly in the brightness of its photon ring or the echoes in its gravitational waves. We have looked. The Event Horizon Telescope gave us a ring from the heart of M87 and one from our own galaxy's center. They look like black holes to within our current resolution. The gravitational waves we have recorded from colliding compact objects match the songs of black holes and neutron stars as we understand them. No unmistakable wormhole signature has yet emerged. If they exist in nature, they are not common, or they are subtle, or both. Why the scarcity? Perhaps because to make a stable macroscopic throat, the universe must arrange negative energy in a coherent way, and that is not its habit at large scales. Perhaps quantum inequalities forbid it. Perhaps the same back reaction that threatened to flood the tunnel with radiation in our thought experiments chokes real ones before they can grow. Even so, the idea of inside persists, because wormhole might be a way to talk about deeper truths. About how space can be emergent, how distance can be a measure of entanglement, how information flows through the world. In that sense, to ask what happens inside is to ask how the universe knits itself. But there is another corridor in this house of ideas. It opens when you bring time fully into the picture, not just as a label for events, but as a companion to space that can be rearranged by motion and gravity. A traversable wormhole, with two mouths that can be moved relative to one another, tempts a remarkable possibility: time travel. If one mouth is accelerated, taken on a high-speed journey, and then returned, time dilation will cause the clocks at the two mouths to disagree. Through the throat, you might step from one now into another's yesterday. The mind leans toward paradox when it hears this. Grandfathers, loops, contradictions. But the universe, in its quiet wisdom, may have protections against such mischief. Or it may permit only those loops that do not shred consistency. What would it feel like inside the throat of time? Would the air taste like memory? Would your skin prickle with the awareness of too many possible futures? We will walk that hallway gently. We will listen for the rules that keep stories from tearing. We will stand, as always, in a place between what the equations admit and what the world allows. And then we will come back to where we began. The night, the moth, the soft work of breathing. We will remember that even asking these questions is a kind of traveling. Time is the ocean that carries us whether we swim or float. In relativity, time can be stirred. Clocks can be coaxed to disagree by motion, by gravity, by the way we choose to move through spacetime's weave. A wormhole with two mouths is not just a bridge in space. It is a bridge in spacetime. If the mouths age differently, then the tunnel may connect moments as well as places. Imagine you keep one mouth here, anchored near a quiet star. You take the other mouth on a journey, a fast loop through space, accelerating hard, then coasting, then braking, then returning. When the two mouths are brought back near each other, their clocks are no longer in lockstep. One has experienced less time, thanks to the time dilation that special relativity teaches us about. If the throat holds steady through this ballet, stepping into one mouth and out of the other could mean walking from a Tuesday into a Monday or into a Wednesday. The wormhole becomes, in principle, a time machine. This idea invites paradox, like a candle invites moths. Could you send a message to prevent your own sending? Could a traveler close a loop that changes its own cause? Physicists respond not with panic, but with principles. The Novikov self-consistency principle suggests that if closed time-like curves exist, loops in spacetime, along which a traveler can move and meet their own past, then only those events that are globally consistent can occur. Attempts to generate contradictions fail by the very mechanics of the world. If you try to break the loop, something thwarts you, a slip, a delay, a missing key, because only consistent histories are allowed. Stephen Hawking proposed a different safeguard, the chronology protection conjecture. Perhaps the universe simply does not permit time machines. Perhaps quantum effects grow wild whenever a would-be loop is about to be born, flooding the region with energy, snapping the geometry like a branch under too much snow. The same back reaction that threatened traversable wormholes might, in this context, act as a police officer with a sunny disposition. Not cruel, but firm. No mistakes with time. Not today. Do we know which of these is true? We do not. What we have are models where loops are allowed but tamed, and arguments that they cannot be stabilized. We have spacetimes that host wormholes with mouths that can be slid around to make mischief, and calculations that suggest quantum fields will not allow the mischief to settle. We have paradoxes written down like puzzles, and resolutions that satisfy the bookkeeper of causality. And we have, above all, the silence of experiment. We have no time machines on the lawn. We have the old arrow, still pointing forward, as the coffee cools and the leaves fall and we grow. This becomes part of the feeling of inside. If a wormhole knows anything, it knows the difference between possible in principle and realized in nature. Inside it, the rules of relativity are whispered with a gentleness that is not the same as permission. You may pass, the geometry says, but only if you respect the accounting of energy, the limits of quantum kindness, the etiquette of causality. Be a good guest. What, finally, is the meaning of this interior? If you could linger in the middle of the throat suspended, weightless, listening, you might hear the softest version of a truth our species keeps discovering, that the universe is woven from relationships. Matter tells space how to curve. Space tells matter how to move. Quantum fields sing to one another across emptiness with correlations we call entanglement. Information shapes, geometry shapes information in a quiet conversation that builds the rooms we live in. Inside a wormhole, you would feel that conversation become physical. Your motion would be the geometry's answer to the matter that sustains it. The light around you would write calligraphy on the walls of space. The view ahead would be a promise kept by mathematics, and the view behind would be a memory stitched with care to the place you came from. You would arrive not by breaking the speed of light, but by respecting the architecture that allows the swiftest legal path. It is, in a way, a lesson about shortcuts. The best ones are not cheats. They are expressions of deep understanding. If large, kindly wormholes are not part of our cosmos, the idea still does a service. It teaches us how to read geometry as more than a map. It teaches us to think of distance as something negotiable, of time as something sensitive, of space as something that can be engineered through the arrangement of energy and the patterning of information. It puts us in the habit of asking gentle, precise questions about extreme places. What would a traveler feel? What would a clock say? What would light do? And in answering those, we nurture our capacity for both wonder and care. Perhaps, too, wormholes are metaphors we can keep, even if ships never cross them. We build our own tunnels every day, between minds with language, between times with memory, between lonely islands of experience with compassion. The negative energy that holds a throat open might be like the rare resources of attention and kindness that hold open the passageways between people, allowing what is distant to be brought near, allowing what is difficult to be made traversable. So, what happens inside a wormhole? Geometry becomes intimate. Distance becomes negotiable. Light paints with a different brush. Time, always dignified, shows its flexibility. If the tunnel is true, Your body travels a path that is lawful and kind. If the tunnel is only an idea, your mind travels anyway, through a corridor of thought that connects curiosity to understanding. Let's return to the night for a last moment. The moth has gone. The train is far. You are lying under a sky that does not know you individually, and yet includes you entirely. The stars are still breathing. Somewhere, a galaxy has collided with another and braided their arms. Somewhere else, a particle in a vacuum flickered into a brief negative mood between two mirrors. The universe makes and unmakes tunnels of many kinds. Some we can walk through, some we can only imagine. Your breath goes in. Your breath goes out. The world is quietly extraordinary. Thank you for walking this corridor with me. If you'd like more gentle journeys like this, more soft steps through science, more rooms of wonder you can visit when the day needs a place to rest, you're warmly invited to subscribe and to come back whenever the night asks for a story.